Greetings and welcome to a video on Python modules. A very short, very simple video on Python modules. Start off with, what is a module? Well, let's go to this page to start off the discussion. There's a lot of potential things that you might want to do with programming. Maybe you need some fancy array stuff. Maybe you need to do some base64 encoding. Maybe you need to do some source control or no CSV, comma separated files, for database stuff, decimal operations. Maybe you need some math functions like sine and cosine, etc., etc. There's a lot, like a lot. Now imagine for a moment that instead of having everything broken out like this, all of this was always loaded every time you wanted to run a program. This would create two major problems. Major problem number one, every program would be horrifyingly slow to start because of just having to load in all of this unnecessary overhead. I will be perfectly honest, I don't know what 3/4 of these things do because I've never had any reason to use them. The other problem that you can get is naming conflicts. There's only so many ways that you can phrase certain things, only so many ways you can reference a row or a column or a vector or a list of something, so on and so forth. And so if you try to load all of these at once, you would without question run into naming conflicts. And so we have this concept of a module, a self-contained collection of functions, classes, and variables that are all within a certain broad topic. And how we include those modules is we use the import keyword. Imports must always be the first lines in a program. No exceptions, your imports have to be at the top of the file, period. You just simply say import module name, and that is it. Well, okay, yes, there are more ways that we can do this, but they are irrelevant for this class. This video is intended for Clark State College students taking programming fundamentals. We will never go beyond this with modules in Python. There is considerable more depth to modules than this. This is all we are going to use. Also, on that note, real quick, you will never be expected to go through this list to figure out what you need if you are one of my students. You will be told which module you need if a module is required. Now, to actually use the things that you bring in, it is always module name dot function name or whatever the resource is, variable, class, etc. So in this case, I'm using the square root function. So I say math dot square root. If I needed to use sine, I would say math dot sine, power, math dot pow, so on and so forth. So just real quick, what is this little bit of code here doing? Well, vector normalization. So again, a vector is a way of representing a point in space. In this particular case, representing a point in three-dimensional space, x, y, z. We're getting the components of the vector from the user and calculating the magnitude or the length of the vector, which is done by squaring the components, adding them together, and then taking the square root of them. And then you can normalize the vector or convert it to a unit vector, a vector with a length of 1, by dividing the components by the magnitude. And the reason why this is relevant is pretty much video games. So if I run this code and I enter in, say, 1, 0, 0, I get a magnitude of 1, as expected. If I run the code again and I do 0, 1, 0, magnitude of 1, as expected. But if I have 1, 1, 0, in other words, I am moving forward and to the right simultaneously. Oh, a magnitude of 1.4. So a little bit of history time here. The reason why this is relevant, if you look at speed runs from older games, say the the Quake Rabbit Run, or say the speed runs of Morrowind, you will notice that the speedrunners are always running diagonal. They are almost never traveling in a straight line. That's because, relatively speaking, that is a very computationally expensive line of code. I've got 3 multiplication operations, and then I've got a call to a square root function, which is not cheap, computationally speaking. Now, on a modern processor, you aren't going to notice. Like, it's really nothing on a modern processor. But on a 386 processor that's running in megahertz, not gigahertz, and like tens of megahertz, yes, you are going to notice. And so older games just simply wouldn't do this calculation because, for the most part, you're not going to notice it. Except speedrunners, they notice it. So, again, the point behind this is how you would import the math functionality and then call the square root function by saying math.square root. Again, as a quick summary here, there's way more to Python modules than this, but as far as the context of the Programming Fundamentals class, this is as far with modules as we are going to go. And so with that, I'll talk to you next video.